I'm super excited because I just received our 4 boxes that Jeff Williams sent back up to us from our collab we did a couple weeks ago with him down in his super high-grade gold mine down in Nevada. We have 1 bag out of the 4 that Jeff and I took a representative sample across the vein in a spot that's kind of run-of-mine ore for him in this property. Jeff wanted to know how much gold could be recovered both via assay and gravity recovery from that sample. So we're going to take that bag of ore, I'm going to crush it down, I'm going to pan some out, figure out how much gold I can recover by panning and gravity, and then I'm going to do another sample where we assay it and figure out how much if you just melt it all and collect all the gold into a button. Okay, opened our first box here and look at what he wrote on there. Rich specimen. Nice. I have seen some rich gold ore before, but nothing like this. And look at the gold showing up in the corners. This is unbelievable to me. This is just the dust, just the stuff that leaked through the bag. My mind is just blown away. Look at this stuff. There was like a half a cup of dust, and that's the gold I got. Is that not the craziest thing you've ever seen? Now that we've got all excited about the yellow in the pan that we saw, we're going to do a little bit of an assay. We're going to figure out how much gold Jeff has per ton of rock in these bags. Here's what we're working with. It's maybe about a gallon worth of stuff. Jeff, this is from top of Ray's. So the first thing I'm going to do, it's already pretty small, but I'm going to resurrect this old crusher here. Kind of got it lashed together. But how this works is I feed the material down through here. This plate is stationary, and this plate turns, and the stuff stays in there until it comes out this little slot between them, and it'll fall down into my patented ore sample catcher garbage can lid. And now a lot of you may be asking yourselves, why is he using this old piece of junk when he's got all these fancy hammer mills and shaker tables and all this other stuff? And the reason is, I can get this thing clean, 100% clean, no contamination. We can wipe all this down and make it so there's no contamination between our samples. Here's the stuff from the Rays. And so now I'm going to weigh out a little bit. I'm going to get it all mixed up, powdered, get it all mixed up, and get a pan of it. And we'll see what a pan looks like. I'm going to measure out a certain amount of material. I'm going to pan it, and then I'm going to take another sample, and we'll melt it down and assay it. And that'll give us a pretty good idea of how much gold per ton is in this stuff. All right, now we're going to get a little technical. Here's our sample. I'm going to measure out 1 kilogram on our scale here. Here's our material, right at 1 kilogram. So now I'm going to very carefully pan this out. I'm going to suck out all the free gold I can find, and I'm going to melt it down into a bead. And that's going to tell us how much free gold is in this ore at this grind size. Now after I'm done with all this, I'll smelt a sample, and that'll tell us the total amount of gold per ton in the ore. And I want to make sure that you understand those are 2 different things. The amount of gold that you can gravity recover at a certain grind size may be way different than the amount of gold that's in the ore altogether that's smeltable. All right, got our stuff nice and clean there. It's all in the snuffer bottle. I've pulled the straw out. I'm just going to turn it over my finger and leak it into that little bit of shop towel there. Got a lot more black sand than I was hoping for, but I think the lead will take care of it. All right, well, I've cut off our little bottom of the shop towel there where all our gold is. So I'm going to put that in this cupel. I'm going to take some lead, maybe, I don't know, maybe 10 grams worth. Put it there like that. And we'll put it in the furnace. We'll get it up to about 1800 degrees Fahrenheit. The lead is going to melt and start to oxidize. The oxides are going to be carried off into this cupel and absorbed. And all the gold and silver and other precious metals, if any, are going to not oxidize and stay in a little bead. So I like to preheat my crucibles. Now I can pick up our that part, add the lead on top. There we go. Now we'll let that cook and see what our button weighs. Now we're going to do a quick screen analysis of this stuff. And I've got 3 screens here. I got a 20 mesh screen, that one's a 60, and that one's 100. So I'll measure out about 50 grams of this crushed rock over here, and we'll screen it through these screens, and we'll measure the weight of each sample that sits on top of the screen, and that'll give us a sieve analysis of how fine we ground it. Well, we're doing 100, so we'll do a 100 gram sample. Yeah, I gotta do all of it. And so you just get the screen stacked like that, and then you just shake them. And so almost everything went through a 20 mesh. Here's our 4 cuts. This is the 20 plus. Here's 20 to 60 mesh. Still see the grains in there. Here's 60 to 100. You can still see some of the bigger grains in there, but just barely. And then here's the 100 mesh minus. It's pretty much powder. Well, here we have them weighed out. Here's your 20 plus is about 1 gram. Also, this is percentage since we did 100 grams. So 47 grams or 47%, 20 to 60, 21%, 60 to 100, and 31% minus 100. So that's the sieve analysis results. And that'll tell us kind of how much gold we recovered at this grind size. So if there's a significant amount more gold when we assay the raw material, we will know that there's a lot of gold still tied up in these particles. But if, for example, we get almost the same amount of gold from the panning assay versus the smelting assay, we'll know that we pretty much get all the gold liberated at this grind size. Here's our little bead from our panning experiment. So let me see if I can get this guy out of there. There we go. We'll get it weighed here. 0.022. And here's the beauty of the metric system. So we did 1 kilogram to get 1 metric ton. You multiply that number by 1,000. So you move that decimal spot over 3 places. And that stuff looks like it's about 22 grams per ton. That's about 2/3 of an ounce per ton of gold. And judging by the color, it's not that super shiny yellow gold. Oh, I get my finger out of the way. So I'm probably thinking that's somewhere in the 80% range or so. So realistically, as far as gold content, you're looking at maybe 15 to 18 grams per ton, somewhere in that range. Now we're going to try and do a little smelting assay here. So I like to use 100 grams. So let me get 100 grams weighed out. 100 grams. Soda ash, 50 grams. Borax, 150 grams. Litharge, 25 grams. And 3 grams of just cooking flour for carbon. We'll get that all mixed up. Pour it into a new crucible here. And now we'll put it in our furnace. So for this smelt or this assay, I didn't add any silica because a lot of the gang rock is silica, so there's plenty of silica in there. And I don't need a whole lot of soda ash, but I used a lot of borax to help thin out the silica and make it fluid. Because this material doesn't have a whole lot of sulfides and a lot of it is oxidized, I don't need to add any iron nails like I've done in the past. The litharge that I used should oxidize any little bit of sulfides that are in there, and the carbon in the flour will help reduce any remaining litharge to our lead button that will then collect our gold and come down into the bottom of our cone mold. Here we go. Oh man, that is just, look at that. That is just classic. There's our lead button. The slag, you can see through it. So there's actually a film of slag on that lead button, but it's so clear you can see through it. And then look at this. Look at the slag we made. Hold it up to the light. You can see through it. Oh man, it's just beautiful stuff. Really nice color there. But we'll get our lead button weighed, and we'll get it in the cupelling furnace and figure out how much gold we got in this stuff. So a couple things I want to point out here before we get too much farther. This bigger bead is the one from the panning, but we used a 1 kilogram sample for that. Whoops. And it's quite a bit more gold colored. I don't know if that comes across in the video than this one. And this one is obviously the smaller bead. That's the one that weighs 0.009 grams, and that's from only 100 grams of sample that we ran through the smelting process. This one is quite a bit more silver. So I think earlier in the video I said this one is probably 75% 80 gold to silver ratio. Because this one is more silver colored, this is probably closer to 50-50 gold to silver. So we got 2 different weights we got to deal with it, and 2 different gold concentrations. We'll go over panning first. We started with a 1 kilogram sample of material. I panned that down, sucked the gold out, and got a bead that weighed 0.022 grams once it got melted down and cupelled in the furnace. And that works out, based on the percentage of gold, to be about 16.5 grams of gold that can be recovered per ton. Smelting, we did 100 grams. Got a bead that weighed 0.009 grams. And based on the color, we're estimating it at about 50% gold by weight. But because it's only 50% gold, we end up with 45 grams per ton of gold, or about 1.5 ounces per ton. And if you guys have any questions or comments, you can leave me a comment down below. So thanks again for watching, and we'll see you on the next video.